Hi, welcome to this episode of JAKTALK. My name is Jeff Kinsberg. I'm the founder and visionary behind JAKTOOL, a precision product development company, specializes in bringing ideas from the drawing board to the production floor. Today, we're joined by Jason Johnson, General Manager of the T1 Trust. Welcome, Jason.
Well, thanks for having me.
Did I do good so far?
You're doing great.
Thank you. So we are. This is our first episode on the road, something new, and we are taping in a passenger car. This is a train-related podcast. We're taping in a passenger car that was an observation car called the Williamsport. We are in Ohio, Denison, Ohio, and this passenger car was the private car for the vice president of the Pennsylvania Railroad.
Correct.
We're in good company.
Yes, we are in very good company here. So this would have been the luxury transport around the country in the 1920s, 1930s.
What's new is old. This is pretty good.
Yeah.
So Jason, we met probably half a dozen years ago.
Oh, yeah, that sounds about right.
And I caught interest of the I don't know, is it a restoration or a recreation?
We call it a new build.
New build. Okay. So a new build of a very historically significant steam locomotive that was essentially the pinnacle of steam technology.
Yep. This is the most modern, fastest, technologically advanced steam locomotive of its time. Ended late 1940s. That's where kind of engineering stopped. And then everything went to diesel locomotive technology from that point forward. So that whole era was ended here, and then we're trying to recreate that 75 years later.
So when I met Jason, similar interests. I like trains. We're both at the time we were both business owners, small business owners, and engineering backgrounds, very applied. And what caught my attention to bring JAKTOOL to support the effort was Jason's strategic vision and his ability to lead complex teams to get through the friction of everything fighting you from doing this. Fair?
Yeah, very fair. It's an uphill battle every day.
So this is a battle to design, build, and actually support, run, support, sustain, 1 million pound steam locomotive. And last night we visited one of the components that JAKTOOL supported a few years back, the frame, and we'll pepper in some shots of that. But, this episode focuses on, the engineering of what it takes both programmatically, and technically to build the impossible.
Yes.
And this has been, from our discussions, this has been a passion from junior high.
That's fair. I'd say early junior high, I got involved. One of my mentors was a locomotive engineer in the 30s, 40s on Pennsylvania Railroad and T1s. And I just sit there for hours listening to his stories about the T1s, and I was just fascinated by, and then it blew me away that there's not a single one left in existence anywhere that they have this technologically advanced locomotive that could do 140 miles an hour propelled by coal and water in the 40s and 50s. And we didn't save one. And it just blew me away. And I said back then, man, if I ever get a chance to build one, a steam locomotive, this would be the engine I would build. And everybody laughed at me back then. And here we are in 2025 and we're doing it.
That's amazing. That's amazing. And seeing the progress that you've made in the 6 years I've been a part of the community and working with you, and I've been on a few calls, very, very impressed with the team you pulled together. One of the things that we deal with at work is producibility. And it's not just, hey, this is too big, it doesn't fit in the machine, or I can't get material. This is a lot of the manufacturing techniques that were originally done to build this locomotive are very hard to replicate now in the United States. So you get re-engineering or reimagining a process, re-engineering it to that process to bring it forward. And the frame that we saw last night, this 62 feet long, 70,000 pound weldment, right, was originally a monolithic casting, and it was a big step to commit to this path for producibility, right? Because you had a lot of challenges.
Yeah, and we went around to other shops that do large castings, Norfolk, Virginia, stuff for the Navy, out into Illinois, where they do stuff for the big Caterpillar trucks for a mining industry. And they said they could do it for us. They said it'd take probably 3 castings to do a single casting.
3 tries.
3 tries before they would figure they'd get it right. And I'm looking at $1.5 million, $2 million per try to get it right. So I was looking at $5 to $6 million investment to do as a casting. And we have to go out and raise all of our own money to do this. We don't have some billionaire backing us. It is made up of a lot of small donors. Our average donor is probably $50. We just get a lot of them every month coming in, and that's what keeps us going. Now, we do have the estates, people that pass on, leave us $200,000, or we'll get a grant for $500,000. Those are great, but majority of our income comes from donations in $50, $75 increments. And so with that, we have to be very cognizant of what we spend our money on. So we decided that we could build this as a weldment significantly cheaper than doing it as a casting. And we didn't know how much it was going to cost. We just knew we could do it a lot cheaper. So we went out to, all the frame shops that build frames for locomotives in the entire country, and they all no-quoted us and said, we're not going to do this. What we're asking for is not a frame. They're asking for a truck, a 64-foot long truck. And for those who don't understand, a truck is typically what's underneath of a rail car that has the wheels attached to it, and that holds a much tighter tolerance. And they're typically 20 feet long. So
the no quote was because of the precision required.
Yes. So because over 64 feet, we had plus or minus 1/8 of an inch. And they're like, no, we can't do that. A shop that I'd worked with many times before, very familiar with in Dover, Ohio, called Dover Tank and Plate. And they have their own engineering firm, Pease and House. I sat down with them and just went through the whole process, explained what I'm trying to do, and said, yeah, we can do that. Brought their top fabricator in. We talked through everything. Here's how we're going to do it. Here's what we want to do. He said, yeah, we can do that. And then for under $500,000, we got a frame built that is high precision. And as you saw last night, it's not far from ready to go. So $5 million or $500,000, which is the better, and the outcome is the same. So I have a frame that will, and most people will never see the detail of this frame, which is sad because it is really nice. But once the boiler is on it, once the wheels are all on it, the brake rigging, spring rigging, all the sheet metal, streamlining of the locomotive, the frame essentially disappears. But it's like the foundation of the house. So it's what's underneath the ground supporting the house. It is extremely important. Without that, everything else crumbles below it. So for us, that's the big push on it. And in our organization, it's extremely transparent when we show our donors where we're spending every dollar and how we're spending those dollars. And building that trust has been really the catalyst for us to continue to get as far along as we can. Because we're 11 years into this, and we set out to begin with, we said we'd have it done by 2030. That's been our goal from day one, and we're actually ahead of target right now. We're ahead of schedule where we should be at this point in time. So we're very pleased with that.
Yeah, so I'm going to just backtrack because you mentioned schedule. So your background is mechanical engineer?
Yeah, I'm a degree mechanical engineer and computer engineer. So I bachelor's in both from Kent State University, and been in those industries for many years. I own an engineering firm, which I sold off 4 years ago now, which is kind of hard to believe, but
life goes on.
It does. So those equipped me well for this process to go through, and I mean, all I do, my daily job is solving problems. I tell people, ask what I do. I say I'm a firefighter. All I do is put problems out all day long. Mm-hmm. So,
yeah, I relate to that.
Yeah, I know you do, and I'd say most entrepreneurs do. I've been an entrepreneur now for 22 years on my own, and that's pretty much daily life, and you get used to it and accept it. And those accept it sooner thrive and grow much quicker.
Mm-hmm. So when you sold your firm, what's your role now outside of the T1?
My role now is a partnership in a private equity firm, and we own 6 different companies and a extensive real estate portfolio that we manage. We do a lot of mergers and acquisitions, rolling up companies into our existing companies, and I oversee a lot of that, the day-to-day and monitoring of those companies to keep them profitable.
On 6 hours of sleep.
Yeah, good night, 6 hours. So I'd say 5 hours is probably more of an average night, but 6 hours is usually about where I don't relate to working, I should say, out of the day.
So, one thing that I've caught on from the different calls I've been on with you and your team and listening to you talk is this systems engineering approach. Can you speak to, and as we talk we know what opinions are. Everyone's got them. And I even preface it with, I would have done it this way. I'm not throwing stones, but and what's so interesting is you start to speak about logistical constraints or fundraising, momentum, the marketing aspects. What have been, to make this £1 million thing, right? And to work with, I got to imagine dozens of dedicated, significant suppliers and hundreds of people behind all of this. How do you continue to move this forward systematically?
You have to understand all of the pieces of the puzzle. So it is a very, very complicated process. And I understand very complicated things and can explain them very easily for most people to take the complication out of it. Mm-hmm. In my mind, I see all I'm looking for the problems. Mm-hmm. I go into every situation looking for the problem. And then how do I solve that? And I've already solved it in my head, typically before it even comes out of somebody's mouth. And our problem is we don't have Daddy Warbucks in a big pot of money. Mm-hmm. If I had a huge pot of money, this conversation goes differently. I'm casting the frame. I'm doing this. The cost of building Locomotive right now, we're estimating around $7 to $8 million to build it. If I had lottery money or big dollar money, it probably cost me 15 or 20 million and I could build it. But I'm gonna have the same product at the end of the day for both either $7 million or $15 million. So I have to take a different approach about it. And then I also have to understand the fundraising. People are skeptical. When we first started and announced we were going to do this project, nobody believed we would do it. We had a few donors that would step up and give us, hey, $1,000, I'll take a chance on you. It's a great project. If I lose the money, so be it. And so we had a few of those to help us get going. We sold drawings for $20-$30, T-shirts. We did all the your bake sales and all that to start gaining momentum because we had to do a lot of engineering up front. Nobody wants to donate money for engineering. They want pretty parts. They want something they can touch.
Engineering is not sexy.
Yes, it is, but it's essential. And I understand the essential. I couldn't skip the engineering step. There's no way around it, but I can't fundraise on engineering. Right. Plain and simple. So we had to go get some parts that are sexy to raise money. Mm-hmm. And on a steam locomotive, this has 80-inch diameter wheels. They're massive. And the wheels are hollow, super complicated structures, all cast. So that was one of the first projects I tackled because I could take it. They're about 3,000 pounds. While that's heavy, I can still take it around to different places, shows, and let people touch it, feel it, see it, stand next to it, get a picture with it. So we went heavily on that, and that was my first big part. I got 60 no quotes on it before I got a yes of a foundry that would pour it. We had the patterns. I didn't have a foundry to do it. So finally, persistence paid off. Mm-hmm. Understanding that then once I got that part, then more money started coming in. Well, then we did the cab of the locomotive. Now more money starts coming in. People can touch it, feel it. And I do the nose of the locomotive. Again, now more money comes in. Parts are getting bigger. Then we went to all in. We did more wheels. And then we end up going with the boiler. And say, well, we're going to start manufacturing the boiler of the locomotive. Found a shop in St. Louis to do it. And then away we went. And then everybody's like, well, they couldn't do a boiler. Then we did a boiler. Then they were like, well, they can't build a locomotive frame. It was original one cast piece. You can't do that, so they'll never get it done. They'll just have a boiler and some parts. Now we have a frame. So those voices are becoming more silent as the day goes on and as we process and build this thing. So.
Yeah, I when you think about developing a project schedule, Gantt chart, as with a technical mindset, coming from the engineering discipline, you're thinking about, these are the different stage gates of the program, and let's take, with respect to the engineering piece, the most efficient path, the engineering manufacturing, the most efficient path to the end. But, and this applies to any real project where you have stakeholders that may or may not have the full amount of funding for the program, and you need to show meaningful results to get traction. Sometimes meaningful results are hitting technical milestones. In this case, the sequence of events had a lot to do with putting things out there that people could see to pull on their heartstrings to say, this is going to be real. We can do it. Do you have a Gantt chart with these marketing points in there?
Yeah. So yes, we do. As no engineer goes without having their good old Gantt charts. We probably have 30 different Gantt charts. We have Gantt charts of Gantt charts. Mm-hmm. And it helps keep us on track of where we need to go and what we need to do. But again, a lot of times we're using our gut in this situation because our stakeholders are the donors out there. Mm-hmm. So as money ebbs and flows, comes in and out, what happens a lot of times, we'll get a bunch of money in on a project, and then we turn our focus to actually manufacturing parts. Mm-hmm. We're not focusing on the marketing yet. So then all that starts dropping down. Then we got to turn our focus back to marketing to raise more money, mm-hmm. make more parts. So there's this whole ebb and flow goes through the whole process. And it's been like that for the last 10 years. Persistence is the number one thing to win. I mean, we stay persistent and we end up making it happen. That's what ends up happening. I mean, that's been our secret to the whole thing, is just not giving up. And the people, the naysayers that tell us that we're crazy for doing it and stupid for doing it, and we should be going out and solving world hunger or something of that nature. We feed off of those people to try to help us persevere and make it happen. Everybody has what their passions are, and we're not going to talk bad about anybody's particular passion. This is our passion, and this is something that we want to recreate history. It's no better or worse than what your passion may be, and just we ask that you support that and help us out.
Mm-hmm. So a little bit more detail. I'm going to venture to say that 99.9% of people watching this have never seen in person a Class 1 steam locomotive. So this is very different than, with no disrespect, the tea kettle that you might see at a local tourist railroad.
Yes. This locomotive was built to travel 140 miles an hour, hauling 1,000 tons across America. And it did it every day. The average, and this is in the 1940s. That's the big thing for most people to remember. This isn't the Acela just got going on the Northeast Corridor. Everybody's making a big deal. It's 160 miles an hour between D.C. and Boston. They're doing 140 miles an hour back in the 1940s with steam locomotives across and the railroad right behind where I'm sitting right now. This was a water stop here in Denison, Ohio. For the T1s, it's halfway located between Pittsburgh and Columbus. But they would have done 115, 120 miles an hour just outside of town once they got out of here on the way to St. Louis or Pittsburgh, Harrisburg from here. So, and it is, those aren't just rumors. We have the timetables and paperwork from the original Pennsylvania Railroad showing average speeds of 107, 100. Those are average speeds. You have slow orders in there. You got to slow down to go through towns. So you're averaging over 100 miles an hour on a particular run. Says a lot.
Now, you had a mentor and friend who had firsthand experience running these engines.
Yeah, I heard the stories firsthand from him. He was a fireman for the Pennsylvania Railroad, got drafted into the war, went to Europe, ran steam locomotives over there, come back, was an engineer, and ran these T1s on the Pennsylvania Railroad out of Denison, Ohio, right where we're at here. And he all kinds of stories. He talks about he always carried a rag in his back pocket because it scared the crap out of him running those kind of speeds. But it was necessary to make up time to get to St. Louis. Typically, a lot of times running from here to St. Louis. Train coming from Pittsburgh, it's running an hour late. They have to make up time. And what he would do is carry a rag in his back pocket. He would take that rag, get up in the cab of the locomotive, wipe all the handles down, then take that rag and cover the speedometer. And then he would just run off the signals on the railroad. So if he got clear signals, he would go as fast as it would let him go. He recants one time around Coshocton, Ohio, going on, and that rag vibrated off. It fell, and his speedometer was pegged. The speedometer only went to 120 miles an hour. It was pegged at 120 on it. He said, hurry up, quickly put that speedometer. But they were so smooth and so much power on the locomotive, they had no problem handling it, got up to speed, and just kept going. So that is one particular story that I still can recall word for word from him to this day, and that's probably 35 years later.
What's your vision for where does this locomotive get to run, and do we get to 120?
So the answer to that question is complicated. So there are plenty of railroads, so it'll get to run. Spend most of the time probably operating around 40 miles an hour, just because that's the landscape we're currently in. Mm-hmm. There are additional opportunities out east. Some of the commuter railroads that we could probably go 80 miles an hour with passengers on the train. We do ultimately plan on trying to set the world record. The official world record for is held by the British at 126.6 miles per hour is the official speed record.
And that thing was like half the size.
Oh, yeah, it was tiny. In comparison, it wasn't. Like I said, the T1 will be able to handle that with no problem. The problem is finding a location to do it. Mm-hmm. We will probably take it, and we have a benefactor that will cover our expenses to go to Pueblo, Colorado. That is the FRA's test track facility there. It's set for 200 miles an hour running. There's those crossings. It's a 30-some mile loop, and all the curves are super elevated, so it'll handle high speeds. So getting out there is one battle that we'll have to fight when the time comes. We're not in any current negotiations to get there. Or if I got to put it on a flat car and haul it out there on a flat car and do it, then we'll make that happen. But that is realistically the only place that we can make that happen here in the United States. So,
you gonna sell tickets for 1,000 crazy lunatics hanging out the window?
Unfortunately for that, it's private. Yeah. So we'll have very limited cameras and unfortunately no general public for that, which is kind of a shame. But there is road access. People could be out on the roads there in southern Colorado and watch it happening. But being on the property, probably not realistic.
Mm-hmm. In 2019, I chased the big boy halfway across Iowa, cornfields and zigzagging and lots of dust. same thing. The infrastructure really wasn't there to handle 100 people, fools chasing this thing around, and I can only imagine what this is going to look like.
Yeah, this is a whole other ball game. There's not many things out there that can compete with the big boy being restored. For those that are watching, no idea what we're talking about.
Thank you.
It's the largest steam locomotive operating in the world, and it's a 1.2 million pound locomotive. So it'll still be the largest locomotive after ours is built, but ours will be the fastest. And being most modern locomotive built. So that locomotive was restored in 2017 by the Union Pacific Railroad and still operates for the Union Pacific all around all around their system, mainly out west.
Mm-hmm. So I've got here this title from blueprints to budgets, right? So how did you initially get traction? I know you talked about, small increments of donation and getting a wheel, but, what were some of the, I don't know, relationships, ideas, major stepping stones that move this forward?
There's one that stands out. We took a huge risk in, I want to say 21 after COVID. We've been making parts, working on the boiler heavily through that phase. Had most of the exterior of the boiler put together. And the boiler, remember, is 62, 63 feet long. In its current state weighs 110,000 pounds. When it's completed, it'll be about 160,000 pounds fully done. So I have the whole exterior of the boiler completed, and it's in a shop, and a secure shop that does nuclear reactor work for submarines and all kinds of different chambers for the pharmaceutical industry for making drugs. Mm-hmm. So the sites, I can't bring a lot of people in to see this thing. We have $25,000 maybe sitting in our bank account. And I made the call to basically drain the bank account and haul this boiler to Harrisburg, Pennsylvania, for the Pennsylvania Railroad annual convention.
So this thing's going down the PA Turnpike.
It's going down the PA. We've had a special semi designed for it, rigged to dollies underneath of it. It is essentially its own trailer at that point. And then we hauled it all the way across St. Louis. We bought it here to actually Dover, Ohio, where we had the cab of the locomotive and the nose. I put the cab on and the nose of the locomotive on the boiler right there. And then we continued down the road to Harrisburg for the convention and parked it into a Sheridan parking lot, back of the convention center that they had there. And had an open house so the people at the convention could come see it, but also all of our other donors could come into town and see it. And talking to most people, that was the turning point of the project, that they can come and actually see this thing. We had thousands of people come out over a 3-day period. Mm-hmm. They could touch it, get their pictures with it. They can talk to the people that were building it, working on it. That made it real for the donations. That probably generated somewhere in the neighborhood of $400,000 for us in donations immediately thereafter.
Wow. That was quite the gamble.
It was a huge gamble, but we needed a big play to show people that it's real. They're seeing pictures and video from inside of a facility in St. Louis. Like, yeah, but until you're standing next to it and see how big this actually is, it's pretty amazing. And that was, for me, that was a differentiator moment for, I can stand back and watch the crowds around this thing and think, yeah, we're doing the right thing, and people were truly interested. And I literally have people walking up handing me $10,000 checks, and all they've seen me on is videos on Facebook, and they literally just walk up and just hand you $10,000. It's very humbling in that moment. Like, hey, here, see what we can do with this. No strings attached, nothing. Hope this helps. And I flew in from Texas just to see this. Here you go. And that was an extremely humbling moment for me. And it keeps me going and keeps push to continue this project and see it to its completion.
I can't imagine the feeling you must have had when people that there's no firsthand, affiliation, just trust, confidence. This is like bordering on spiritual, like let's go.
Yeah. And so we adopted early so there's a lot of eyes on us. So we adopted early kind of our standard. We do not announce anything until it's completed, because there's so many roadblocks to get thrown at you in this process. If I go and tell you, hey, I'm going to do X, Y, Z, and I don't complete them, they'll come back and say, see, they were just full of BS. They don't know what they're doing. So I don't give anybody that opportunity to say we don't know what we're doing. So say, yeah, we're going to build a frame. Oh, by the way, here it is. It's done. It's sitting behind us. It's completed now. Next thing, we're going to start working on the cylinders. Oh, here, by the way, the cylinder piece is already cut out. They're sitting behind me. We just got to start machining them. And then we show them pieces of the machining. And then we'll at some point say, oh, well, we're going to weld the cylinders on the frame. Oh, by chance, here they are. It's welded on the frame. Mm-hmm. So taking that philosophy keeps people excited that we say we are going to do what we say we're going to do. And that is huge when you're asking somebody to give you $10,000, $20,000, $30,000.
Right.
And they gotta have a comfort level in their own stomach that we're not going to go out and have our next nonprofit board meeting in Aruba and go blow their money on that. So.
Mm-hmm. Yeah, we were talking about don't need to go down this path, but we both have experience with EOS, and EOS stands for Entrepreneurial Operating System, and we both use it in our daily careers. And it's a simplified way of, you're more learned than I am on this. It's a simplified way of distilling business practices to repeatable and simple processes.
Yeah, predictable. So I'm repeatable and predictable in business that I can tweak to refine those to make them slightly better next time. And that's basically what EOS is designed to do. And when properly implemented, it's extremely powerful in running any company. I would never run a company or an organization without EOS moving forward. And it's one of those things I wish I would have had 30 years ago. 25, 30 years ago. And unfortunately I didn't, but I was able to have a mentor that was a big believer in it and showed me the ways of, and it's worked out real well in what I do in my everyday. I couldn't operate on daily without a system in place, whether that system is EOS or there's plenty of other systems out there for businesses to operate, but that's the one that we chose and I like and continue to operate under. So until something comes along better, then we'll stick with that.
So, there's, and I don't know if you've used this in your working groups, but, we talk about, I'm listening to the words about, creating things, right. And building that trust. And, the saying I've heard and I have fun tossing around being, I've got a visionary and an integrator mix, but I like the visionary piece. And I know you have the same mix as well. Yeah. And I think we both, the vision without traction is hallucination. Right. And, I think how many people have had visions of doing what you want to do and what you are doing, what you're executing. And I think you had to overcome lots of failed attempts and, breaking the mold of the stereotype of saying, here it is.
Well, yeah. I mean, that's the reality of it. We come out and say, hey, we're going to build a steam locomotive. We're going to take 16 years to do it. Like what? But again, that's what the Gantt charts are telling us. We went and looked at other locomotives that were built in the UK. We took all the data and processed all the data and said 2030 is our year. We started this thing in 2014. So to come out and say in 2014, like, hey, we're going to build this steam locomotive. Oh, it's not going to be done until 2030. That's tough to gain traction on, but we just have to continue to show. That's the vision piece. Now we have to change to the integration piece in the background. So it goes to strategic versus tactical. So here's our strategic plan. Now we have the tactical plan that we have to go out and implement and execute on to completion. And if you look at the whole project, it's overwhelming. Say, I'm going to build a $1 million locomotive. I have to manufacture and make every part on this because I can't go buy anything. So I have to make everything from the wheels, to axles, everything. Roller bearings, I mean, the whole 9 yards. If I looked at the whole, it'd be overwhelming, and most people would just quit. And that's what most people have done. When you back it out and use your system and think, all right, now we'll just focus on just this one component. Now, when I break this one component down, here's the steps I got to do to complete that component. Put all of our focus on that, and then get that to completion, get that 100%, and then we pick the next component. And then they all fall in. There's a strategic order, but the tactical is so important on that. And again, going back to the EOS, that's what EOS designed to do is you have your strategic, and then you have your quarterly setup to do your tactical, and you don't change in that quarter your play. You say at the beginning of that quarter, this is what we're doing. We stick with it. If we want to make a change, we do it in the next quarter. We don't do it in this current existing quarter. So, those are the things we take from that to do on a project basis. And sometimes those quarters are a little longer than you want them to be. Everything costs twice as much and takes twice as long. It never fails.
I wish I could tell the customer that.
Yeah, unfortunately, you can't. Especially, like I said, we're essentially building a $1 million prototype.
Right.
And anybody that's ever done manufacturing and done the prototype's the worst thing to do. You're doing a single unit, all your setups, your toolings, all the engineering. It is a super expensive to make one. You go make 10,000. All right, now it's a whole different world. We have no plans of making a second one of these. This is one and done.
A double header would be pretty amazing.
Yes. No, thank you. I don't have it in me on that. So I know my own limitations. And I've been approached by other groups to build other steam locomotives and lead their organizations. And the reality of it is they want me to handle everything, and they sit back and do really nothing on it. And I'm not interested in, this is my passion, and this locomotive in particular. I don't have anything against a New York Central Hudson or one of 100 other engines that people have approached me about helping them put together. But you just have to start and get going. I mean, that's
right.
That's the first step. And the engineering is the hardest part because it takes the longest time.
So I am not going to, I'll give a little bit of the journey, and I'm curious to your perspective. So JAKTOOL has supported engineering CAD for 2 systems on the engine. So the first item was we were provided with the original PRR drawings of the cab of the locomotive, and needed to get the cab, which is an aluminum cab, and that was for weight savings.
Yeah, they cut out about 20,000 pounds of weight of the locomotive by going aluminum. It kept it under. So we say $1 million. The locomotive is 980,000 pounds versus $1 million. The aluminum got them under the $1 million. Our best guess is there were union requirements. They had to pay the crew more if the locomotive was over $1 million. So the CNO was big on that. They lied about their weight of the locomotives, so they didn't have to pay crews as much. All that stuff came out later in documents, but we suspect the same thing with the Penn C. Not that they lied about, but they deliberately designed the locomotive to be just under $1 million, so they didn't have to pay higher wages to crews to operate it.
That's pretty wild. So our first foray was taking these drawings, and I wasn't the one sitting there interpreting, because there's a big interpretation to these drawings, and we'll get to this frame in a second. So this cab, you first need to kind of put yourself back 70, 80 years and look at 2D prints and section views and these elevations. And this is not how designers and engineers think anymore, right? How does this view intersect with that view? And you see all these, you start to model this stuff and you see it doesn't necessarily fit together. And this is one of these things where, and it's not right or wrong. It's, I talk to people about drawings are drawings are a communication tool. And it's really between, the designer and the builder. And if it works, if you got to the right end, that's all that mattered, because anyone can nitpick anything. But, time and money and limited of both. So it was just so interesting where you would model some of the pieces, and they might be off by a fraction of an inch. Who cares? Some guys there with a hammer, and you beat it into shape, and you weld it or riveted it down, and you move on. It was close enough.
Yeah.
So that was really exciting, and I remember seeing when you sent me photos of the cutouts for like the windows, like the very, very prominent Art Deco design of so Raymond Loewy, right? He was a famous industrial designer, had his signature on the styling of this,
he's the same one that did the Studebaker Coca-Cola logo, Coca-Cola bottles. That was his. The other day you had Henry Dreyfuss and Loewy were the two main industrial designers that everybody went to design their products. And so Loewy was one that the Pennsylvania. The thing you have to remember is post-World War II, the railroads were competing against airlines for the first time. So TWA was Pennsylvania Railroad's biggest competitor. So they need to make streamlined-looking locomotives. Everything had to be
to the future.
To compete with the airlines, which ultimately we all know they would lose to that as the airlines matured. But that was the thought process, and so that's why bringing Loewy in to do these designs to compete with TWA and cross country travel.
Mm-hmm. So you had the cab and locomotive built,
yep.
And I remember seeing photos of that on a trailer, and friends of mine took selfies in the cab, and they're sending me photos, which was pretty exciting.
Yeah.
Like you get that energy of it's happening, it's real.
Well, and we've used a lot of different shops around the country to build a lot of these parts. It is amazing when we do the open houses and bring stuff out there, how far employees of those companies will travel to come see the finished components together, and just they all feel part of it. A lot of this is being part of something bigger than yourself, and that's what this project really is.
That's a team.
It is, and so now the team is made up of hundreds of people all over the country that had their hand in building this locomotive. So when this thing operates, by the time it operates, there'll be thousands of people around the country that have had their hand in building this locomotive. So they're all going to bring their kids, their grandkids, their wives, husbands out to see this thing run and say, look, and stand with a bit of pride at a crossing, and this thing comes whipping through a crossing 40, 50 miles an hour with 1,000 people waving behind it, smiling and happy to be on board the train. That's what will give them a sense of pride that no paycheck ever got them. Mm-hmm. They'll never open up the paycheck in their life and felt the same way they felt that moment when that locomotive came by them. Mm-hmm. And that's the feeling that I'm going for.
I'm getting the feeling sitting here with you.
Yeah. And I will guarantee, hopefully you had a little bit of that feeling last night when you looked at the frame to see that from all the work that your team did to make that happen. And like, here it is sitting on a trailer waiting for the cylinders to get done so we can get it done. And then it's complete and it's ready to go. And, your whole team had a factor in all that. We wouldn't be here without that, or wouldn't be as far along as we are.
I had no idea what I was getting into.
So I would highly recommend that for most people to dive in. Don't overanalyze it, because if you know how much work it is, you won't do it. And this is one of those projects too. It is for me, it was the driver, the first wheel that we did. I had no idea how much work it would be to create that wheel and how complicated that was and get somebody in it. So
yeah. Just to touch on this frame, I believe it's a J size drawing, which is, printed. It's like 14 feet long, and we get the original high fidelity scan drawings from you. Yep. And this is the drawing. It's, you see people who take these relic drawings and they hang them up as art. It's art. Now you got to take this drawing, which should, again, there's a difference between reality where you can hit it with a hammer, or in the case of the frame, you massage the pattern a certain way and it's close enough, versus trying to solve a mathematical model in the computer. It's binary. It either fits, or why doesn't this surface get there? Right. So we put, and it wasn't me, it was really talented people on the team who had the patience of a saint to look at this. And we modeled it in SolidWorks. And this, I challenge people. So you have pictures, you've got the CAD, but you have pictures, the rendering of the as cast frame on the PRR T1 website. Somebody show me a more complicated part.
You won't find one.
I've never seen. So when this thing got done, the CAD itself is a work of art. And to think that teams of people visualize this without CAD is amazing.
Yeah. No, like I said, I mean, slide rules and pen and paper, or pencil and paper. That was it. That was how they did it, and it obviously worked out quite well for them. So they were quite successful.
Yeah,
they built 52 of them. So
yeah,
did something right.
So we're sitting. So we are in Denison, Ohio. So we're talking about facilities and what's next. So where do where does this get built?
Yeah, so we did announce earlier this year that we received a grant to build a building right behind me where I sit right now here in Denison, Ohio, that will probably hopefully break ground yet this year in 25, and be able to move in sometime late summer of 26 and start assembling the locomotive there. And the shop will be used to restore passenger cars, work on diesel locomotives, but also assemble
that are behind you.
Yep, and be able to assemble steam locomotive, the T1. So over the next 5 years of the assembly process, final assembly, which is something we talked to a lot of shops around the country and a lot of opportunities, and this opportunity came up, and we're a better place. In Denison, they had built 75 steam locomotives in the 1800s here from scratch. So what more fitting way? This is a Pennsylvania Railroad depot, Pennsylvania Railroad line, and the T1s actually operated here in Denison. There was 12 of them that operated through here every day. So there was hard to find a more fitting place for the T1s than here, and to assemble it. So that's what led us to it, and that's our plan as of right now. And we have the funding in place, and we're just going through a final environmental review so we can start breaking ground and start spending some money.
That's fantastic. Yeah. Just, walking the grounds here with you earlier, this is such a fitting location to do this. I can see it. It is special.
Yeah. Yeah. And like I said, the Denison Railroad Depot Museum has been here since 1985, and it is a staple in this small community. And, tens of thousands of people come through here every year riding trains or just visiting the museum. And we're going to give them something else to, we'll have open houses occasionally, and scheduled tours of the facility so people can come through and see the locomotive being assembled.
So as we kind of wind down, as we've got real progress. I'm knocking on wood. We're going to get to the end here. Of this build. What are I guess how does it feel? There's this channel is this channel is frequented by engineers who are in at some point in their career who want to build great things with great teams, and you're doing that. How does that feel? And any advice?
Yeah, no, it feels great. You have to think big. The problem that majority of people have today is thinking small and quick. And if you take a think big and long, you will change the world. And whether that world is in trains, if it's in race cars, if it's in whatever your passion is, if you take that approach, think big and long, you're going to do so much better in your career, rather than have a bunch of short victories. Everybody can have short victories. And this is the world of the social media and the TikTok. Everything's immediate gratification. But we're showing, so I was saying, I said, you can either talk about something or give people something to talk about. I've chosen the latter. There is we are the content creators rather than consumers. So you're either consuming content or creating content. You have two choices. That's it. So which of those two are you going to be as an engineer? So are you going to just continue to make little widgets and little designs, or are you going to think bold, go big, and create the next JAKTOOL company, or you create the next Formula One race team that's just going to dominate? Whatever the case may be, whatever your passion is, don't put constraints too small. Mm-hmm. You got to think big, because one, you're eliminating 99% of your competition because everybody else is thinking small. Mm-hmm. So you go big, then you've eliminated a lot of your competition at that point. And you will be, and people want to be inspired, and they're not inspired by the next little widget mm-hmm. that's made that's your little household item that doesn't move the needle. So
nobody got excited over a can opener.
No. But it's needed.
Yep.
I don't want to, I don't want to diminish the need of a can opener.
We need can.
But the reality of it is, if you want to make a difference and you are truly want to inspire other people and build team, if you go big enough on a project, it is so easy to inspire. I don't have to, it's very easy for me to inspire people to do this. The project itself is doing it. Mm-hmm. I'm just helping guide those paths down there and help others see the vision. Mm-hmm.
So Jason, how can we will put links, so thank you for arranging this. Thank you to the Denison Railroad Museum. Thank you to the P1 Trust and yourself. This is a best shoot I've been on. What can the viewers do to help?
So again, we are a 501c3, fully nonprofit. There are zero salaries taken from the management of this thing. It's 100% donation on our end, time, energy. We get paid nothing. We just want to see the project completed. So every dollar goes to steel. Mm-hmm. We don't even use them. We use private money for marketing and promotional stuff. We don't even use donations for that. Any donations can be given, whether it's $5 or $50,000. We're open to it, and we have all kinds of opportunities on our website to sponsor different pieces, parts, the frame, the cylinders, the boiler, in different parts of our clubs. Mm-hmm. We've got rail cars stuff moving behind us on the active railroad here. So,
yep.
So T1Trust.com is a good place to start. Visiting our Facebook page is probably the most active community that we have of stuff going on. Our YouTube page, there's a lot of different content out there. So you can easily go down that rabbit hole on our YouTube page, watch all our videos and seeing how we've gotten to where we are here. So
thank you.
Yes.
I think this is the common thread here. What I like, we both love challenges, and it's all about finding a good challenge and finding great people to work with. And, it's kind of one of JAKTOOL's call to action is, let's build great things together. And that's what you're doing and leading here. And just want to say thank you.
Hey, thank you for having me. It's been a pleasure. I always enjoy talking about how we got here, mm-hmm. where we're going.
So we'll put all the links below. And please take a look at the PRR T1 Trust website, Facebook page, YouTube. And if you found this interesting, please like and subscribe to our channel as well. And until next time, thank you.